Good morning, friends. We are in the third episode of Geogebra software, and today we will be discussing about the functions, functions and Geogebra. We will see that how Geogebra very efficiently sketch a function uh, with the help of just description of the function in the algebra window. Clear? So it is very interesting and important topic. So let us try to do that. For example, we go to the GeoGebra this thing, and as usual we choose this mode of GeoGebra, and you have this graph paper and the instructions site, that is this site, that is the algebra site here. Okay, now for example, writing function is very simple. For example, you write a function straight line, say 2x plus 3, 2x plus 3, and this will be the function y is equal to mx plus 3. How simple it is, isn't it? You can draw various other functions. For example, you can draw a parabola passing through whose vertex is at origin, and you see your parabola is ready and in scale. Okay, so writing function is so easy in GeoGebra. Now I will hide this too. Uh, Whenever necessary, we'll refer to this, or we can just clean the board by making undo like this. Now I will write one interesting function, or rather the trigonometric functions. Let me talk about that. So you can write sine of, you give a brace x, the other syntax it will produce. GeoGebra is smart enough to understand what we are going to do. So sine, keep a blank and then type x. That's correct syntax of sine x is there, and you get the sine wave with amplitude 1 and frequency is also 1 radian per second, just like that. Okay, so it is there, but I will now so in this way any function, reasonable function I suppose, can be very easily sketched in your graph paper window here, this side, and you can get a fair idea of that function. Okay, for example, another, let me write just like that. For example, you write a function x to the power, sorry, x to the power, small x in terms, x to the power, say 1.5, and the function will be like that. Okay, and for this function there is no left hand side, because that will be an imaginary number, root over minus 1 will come, 1.5 is there, so it means that it is x into x to the power 0.5. 0.5 means under root x. So this function does not exist for minus 1, so it will clip that side and you will get this portion. Okay, so this is how you sketch of your function. You simply type it here and get your function ready. Clear? Now I will try to sketch. As I told you, I sketched one trigonometric function, say sine function or cosine function, isn't it? So for example, you can also add two functions here in the instruction sheet here and get the resultant function. For example, if you write sin x with a blank and then plus of cos x, you will be having this function. You know, this is the equation of a function. If you divide by root 2, multiply it by root 2, it will be root 2 sine x plus pi by 4, isn't it? You know that. So this curve does not pass origin as expected, and you get this function. So you can add any functions, addition, subtraction you can do and straight away write. For example, if you add plus 2 to this, it will be a shifted up sine function. This sine function or this trigonometric function gets shifted up by a division of 2. So it is like that. In this fashion you can do. And also you can plot the absolute value of that function. For example, sine function, as its x value is changed, it will have both positive and negative value periodically, as we have seen earlier. But you can also I hope you can plot it, absolute value of absolute values of, say, sine of x. So you get that negative half is reversed to the positive half. Okay, so you can do several things. So absolute values of sine x will be always positive, and you can easily sketch them. Got the point? So sketching and plotting of functions is so simple, I tell you, and it gives you a visual idea of the function. Whenever maths is picturized in this way, I hope everybody is delighted and you can get the idea. Now I will do something more here. For example, I clean the board and then I will now do, I want to sketch this. For example, I write, sketch a function a sine of x. Sorry, give a gap, otherwise. This function, and you know by this time what GeoGebra is going to do. It reads your mind and thinks that the amplitude a of this sine function you have not defined, means you want to see how it looks like when the value of a is varied. Therefore, it is expected to create a slider with a. We have learned this in our earlier lectures, and the default value of a, the amplitude of this sine function, is at 1, as we know, and you get this waveform. Got the point? And if you change the value of a, you can easily see the amplitude of this sine wave changes, and how it changes you can easily understand. Okay, and if you play it, it will do this way. Okay, this wave is called a standing pulsating wave. Is it standing pulsating wave. The wave pattern does not move here and there. It is this he 0 to pi, it remains there, but only amplitude changes. Very nice. Okay, so standing pulsating wave is created just by using this one. You can stop playing this, and where it stops, that value of A it shows, it is negative of this one is the amplitude at pi by 2, and so on. So this is the way one can easily sketch many functions. I will give you much more example, but one thing at this point I would like to tell you about, not really about maths, but how this function, if you as you vary A, the function changes, we have seen like this. But if you want to keep a trace of the functions, how it will look like. Okay, the trace of this function object fx, if I want to do. So for that, what I have to do, I have to go to its settings, as I told you earlier, and activate your show trace option. That's all. And then if you play this out, you will see it will do like this, and it oscillates. The choice of this variation of A has been set in oscillating mode, which I can of course change whenever I feel like, but this is how it will look like. A nice pattern, is it not? To make it a little bit more colorful, I will, at this point only, I will tell you as the position of this sine curve, because of this trace option given, it will occupy different positions, sine wave, depending upon the value of A. But suppose, can I make it multicolor? That is, depending upon the amplitude value, the color of this sine function will go on changing. Perhaps it will look much more exciting, so to say. Let us try that. And with that thing, I will also bring out another important thing, because whenever you sketch several curves, you know, you have to plot those curves maybe with different colors, isn't it? So those things are necessary when you want to prepare a document, that this function should be drawn in color blue, that color black, and so on. But here in this animated view of this standing pulsating wave A sin x, I want to sketch those waveforms in different colors depending upon the value of A. That is my goal is. So you can remove the trace. The function is like this. Now you go to this one, you listen carefully, and this is so interesting, I am telling you. So you go there, go to setting. Now here there is a color option. It can be chosen, but I will not do that. I will go to this advanced setting. See the power of this advanced setting. You click that, and here is this color options can be chosen, whether it will be RGB standard one, or you want to some HSB, of which HSL is very interesting. Hues, the main color, and let us see, saturation and lightness. Okay, hue is the main color of this one, and this value should be between 0 to 1, like that. But anyway, you need not be so much worried about scratch your hands about how to put the values. But one interesting thing is you can, because of this default values taken here, this color appears to be somewhat green, isn't it? But I want to change the color as the value of A changes. For example, if you now vary A, it once again remains same color. Got the point? That I don't want to do. I want to change the color as the value of A is being varied. How to do it? So I will go to once again HSL here, and there this one condition to show the object, here you can write down the equation or any mathematical expression there. This is most interesting part. You can write some mathematical expression which will be function of this small a, and the color will be decided by that. Not there, here in the hue you can you choose this HSL. In the hue you write the main color. You can write what I am repeating. You can write any mathematical expression involving A, and as the value of A will vary, that expression value too will vary, and naturally the hue, main color of this curve will change. Very simple idea. Now the question is, which expression should I write? See, here the value of A changes between -5 to +5. It should be a positive number, they say. But anyway, I will write it to avoid any confusion. What I will do, I will say that take absolute value of A, and so absolute value will be between then 0 to 5, and divide this by 5. Where is that fellow gone? I'm sorry, I have to once again go there. Here, HSL. So here what I will do, I will say that this one is absolute value of A. Carefully follow me, and this divided by, I will make 5, because its value will be 0 to 5, so it will be always between 0 to 1. So you do like this, and saturation you set it 1 maximum, and lightness you make it give some value, okay, 0.7 say, like this you give, okay, how light that color will be, something like that. Now with this, let us try to see what is happening now. Hopefully things will work. Now if you vary A, you see it shows multiple color. Very nice, at least in its appearance and looking. Got the point? So I repeat, what you do, you go to its setting of this function, and then you choose advanced, where I have already entered. Hue is the main color, which is I have made it a function of A. Any expression you can write, okay? Maybe log A or things like that you can try. That I leave it to you, okay? Maybe A squared by 25, for example. Let me try that, whether it works. For example, you write it will be a function of this A square and maximum value of a square will going to be 25, and divide by 25, suppose I do, sorry, divided by 25, clear, a square by 25, saturation 1, let us see whether things changes. We'll move it like this. Once again the color changes, but this time in a different way. Got the point? So any expression can be written, any reasonable expression of course, can be written which you make a function of a and get this one. Got the point? I hope you have got the point. And you can try on your own other things. My job is to just initiate to you what are the controls you have at your disposal to make a nice way of representing a curve in which some parameter is changed. Got the point? Here in this case the parameter a is being changed. Acha. Just to conclude this one, because I have gone to from functions and I have taken a particular function, and then I have tried to explain to you how its color can be changed. Now, what you can do this about the setting of the screen. I have so far told you how to, what are these three dots. These three dots correspond to the setting of each of this object on this side. Now, where can I control this screen, the graph paper? The setting of that is here. Okay, in the graph paper, if you want to change x-axis, y-axis, that can be done with the help of the mouse click, as well as you can do it from here. So if you press this setting, here you see it is already there, show axis, show grids. It is there. What I will do, I will say that don't show axis. So axes are not shown. Then I will also say no grid. No grid. So it is a white piece of paper, and you are doing this. Now the background color of this white, which is presently white, can be changed to, for example, you go to basics, here there will be some in the basics, under this basics, there is something, background color, which is in default white. I will now make it a bit darker. For example, you choose this one. Okay. Now it will be like this. So what happens when you are displaying thing in multicolor graphs? It is better you have a slightly darker background, so the impression is so impressive impression on our minds, and visually it is so attractive. For example, now if you play this, it looks so nice, beautiful, isn't it? Got the idea? So I will stop this lecture now, and I will request you to go through this carefully, particularly how the color can be changed. Writing functions is very simple. You can try many other functions. I will continue with this in my next lecture. So this is lecture 3, which I conclude now. Thank you for viewing this. Hope you have enjoyed.